everybody. Welcome to Water STEM Live, the science of what's possible for kids. My name is Maureen DeLaffey. I work in the Water's headquarters in Milford, Massachusetts. And I'm at home today, of course, but I'm bringing you this awesome experiment. It's called the 6-layer density column. And I have the materials here in front of me. What we're going to do is we're going to learn about what density is, what it means, and then we'll do an experiment where we can measure, compare the densities of these regular household items. So first I'll explain a little bit of what density means. So if you think about how heavy something feels in your hand, that's a good way to think about it. It's basically a way to describe how much space something takes up relative to how much mass is in that item. So if you think about like a nice fluffy pillow, it takes up a lot of space, but it doesn't weigh that much compared to something like a brick. So it's a lot smaller, but it has more density or a higher density because relative to the pillow, they might weigh the same amount, they have the same mass, but the brick is more dense because it takes up less space than the pillow. Or you could think about it the other way too, like if you have two items that take up the same amount of space, they have the same volume, but they have different masses. That means that they will weigh very different amounts, even though they take up the same amount of space. So today's density experiment, we're going to take 6 different liquids here, and we're going to stack them up into this, what I'm calling the density column. So the column is going to have honey, which is our most dense liquid, and I have corn syrup, which I put a little bit of food coloring in to make it just stand out a little bit. That's optional. It's normally a clear or slightly yellow liquid. I have blue dish soap, and I have water, which I colored a little bit orangey red just to make it easier to see. I have vegetable oil, and finally I have, this is rubbing alcohol. Now I kept it in this container just to start because it has a little bit of a smell to it, but I'll pour it into my cup. I'm just trying to get the same amount here. There we go. Okay. So our 6 different liquids, they, like I was talking about density, they have roughly the same amount of liquid. It's all the same volume, but because they have different masses, different amounts of material per volume, they have different densities. So the honey is the most dense of the liquids. So what we're going to do is we're going to stack these liquids into this column. Now, if you're using the rubbing alcohol, this is kind of an optional layer in our column. You just want to make sure that you have an adult's help before you do that because it's a bit of a stronger chemical than the rest of the items here. So once you have all your liquids measured out and you have equal amounts of each one in your small containers, you can start layering them into your cylinder. So the cylinder I'm using is a little bit big, just so it can be seen on the camera. But if you had, what I did beforehand was I measured how much volume would fill this cylinder, and then I just divided it by 6 so that I pre-measured all of my liquids here. So I have about half a cup or about 60 milliliters of each liquid. So what I'm going to do is I'm going to start by pouring my honey right into the center of my cylinder. And let me see if I can reach for this spoon carefully. What you want to be sure of and be careful with is make sure that you don't get any honey down the side of your cylinder. You want to be careful and pour nice and slow right in the middle. So I've almost got it all. It's a little bit sticky. There we go. All right. And then I have this bowl of soapy water here. I'm just going to give my spoon a little rinse between the liquids. The next is the corn syrup. So it's the same as the honey. You want to pour it right in the center, nice and carefully. And what you'll see is that the corn syrup has less density than the honey, so it should float right on top of the honey. So what that means is we have a half a cup or 60 milliliters approximately of honey, and we have the same amount of corn syrup. So since it's the same amount relative, the volume is constant, but they have different masses. That means that the density of the corn syrup is lower than the density of the honey, and that's why it floats right on top. So let's check. I'll hold this up, and I hope you can see that on the camera. I've got two different layers, the honey on the bottom and the corn syrup on top of it. I hope you can see that. And now I'll do my blue dish soap. So the blue dish soap, I'm actually going to start using I have a turkey baster here, and I'm going to very carefully layer the dish soap on top of my corn syrup. This is where it gets a little trickier. You want to go nice and slow and dribble it in real gently, just to make sure that this dish soap floats nicely on top of that corn syrup layer. So I'm taking my time. I think out of all the layers, this is the trickiest to put into your cylinder. So don't be afraid to take your time, and bear with me while I take my time here. I might just hold this so I can see a little bit better what I'm doing. All right. Good. I'm gonna keep going. So while I'm doing this, I think I'll talk a little bit about what we're gonna do next. So once we get our 6-layer density column assembled or stacked up, or however you would like to refer to it, what we're going to do is we will be dropping test items into it to compare their relative densities. So we will be able to tell which items are more dense and which items are less dense, and that will be based on where they sit or where they float or where they suspend in the layers of liquids. So I'm almost done here. This is taking a bit of time. The other 3 layers will go a little quicker. Like I said, this is the trickiest one. And the reason this one is tricky is because the density of the dish soap and the density of the corn syrup are actually pretty close to each other, I think. So they tend to want to mix a little at the layer between. So I think that the density of honey, or the density of liquids, is measured in usually grams per milliliter. And you can compare them by looking up on an internet search. If you type in like density of honey, it will give you the number. I think it's like 1.4 grams per milliliter. And just for a comparison, the density of water is about 1.0. That's by convention. So honey is a lot more dense than water compared to the corn syrup, which is somewhere 1.3 maybe. Now for let's see how we're doing here. All right, so I hope you can see that nice. I've got my 3 layers, my honey, my corn syrup, and my dish soap, and it's starting to look pretty good. I'm going to keep going. Now I have water. So when you get to these less viscous liquids like water. It sloshes a lot easier than, say, a dish soap or a honey, where it wouldn't really slosh in the cup. Instead of putting it in the center of your cylinder, you want to gently pour it down the side of the wall. So I'm going to try to hold this up and show you. So I'm running it right down the side of my wall. And I'm going to put it down so I can be a little careful while I do this. Because again, I think the water and the dish syrup are fairly close in density, so they're a little harder to stack. But the other thing that we can do is allow a little bit of time between building the layers for everything to settle out. And because the liquids do have different densities, they will even out over time, as long as we don't move or bump our column too much. So I'm just going to keep going here. And I hope everyone can see. There we go. Almost done with the water. So like I said, the density of water is 1.0 grams per milliliter. So that means if you had 1 milliliter, which is a very small amount of water, it weighs 1 gram. And let's check on our layers. Beautiful. I hope you can see that. And my next layer is vegetable oil. So it's yellow, light yellow, pale yellow. And same as the water, I'm going to carefully run it down the side wall of my cylinder. And this is the easiest layer to put on because just by luck, these two, the oil and water, we know they don't like to mix. I think in Jen Fournier's experiment from a couple of weeks ago, she mentioned hydrophobicity. So oil is what we can call hydrophobic. That means it does not like water. So that's why they don't like to mix. So this layer is really easy to do. But you would know that the oil is less dense than water because it floats on top instead of sinking below the water. So there we go. Almost done with the oil. And I left some space in my cylinder because I wanted to make sure that it doesn't overflow when I start dropping my test items in. So there we go. Let's see. Hold it up. Doing pretty good. I've got 5 of my 6 layers in. And the last layer is my rubbing alcohol. So remember, this is with adult help only, please. And I'll float this right on top. So the rubbing alcohol is a mixture of what's called isopropanol and water. So I think I'm using 70%, which means it's 70% isopropanol and 30% water. And I know that the density of 100% isopropanol is probably 0.79 grams per milliliter. So that means the density of this mixture is a little bit higher than that because we know the mixture of water and isopropanol, 70-30. And I'm going to wiggle my computer there so I don't lose my screen in case I need it. But all right, last little bit here. Okay. So here's what we ended up with. We have our 6-layer density column right there. I might actually put a tiny bit more isopropanol. I think when I poured it into the cup, I was a little short of my desired volume. So there we go. Now I'm going to try not to move this so much. So now that we have this density column all assembled, we can start looking at our test objects, our regular household items that we want to compare the density of. So I have a few here. I have just a regular screw. It's made of steel. I have a little brick. I hope you can see what I'm holding up. I have a game die. I have a grape tomato. This is a dried cranberry. I have a regular red grape, a clove of garlic, an almond. This is made of wood. It's just a ring, but it's made of some kind of wood. I'm not exactly sure which type. And a ping pong ball. So I think if anyone has any guesses about the density of a screw compared to all these liquids, if you think about how heavy a piece of metal feels compared to a liquid, you could probably guess. But I'm going to drop this screw in and see what happens. So I carefully put it right in the middle, and I will hold it up, and I hope the camera's picking it up, but if not, I will say that the screw sank all the way to the bottom, and it's resting on the bottom of my cylinder. So that means that the screw is more dense than all 6 of these liquids because it doesn't float anywhere in there. So if I think my die is also, my game die is also very dense. So let's drop that in and we'll see where it falls. Aha! Okay, so the game die came to rest right in the layer of the corn syrup there. Actually, I think it's sliding ever so slowly down. So that means that the game die has approximately the same density as that layer of corn syrup. So that means that its mass per unit volume is similar to corn syrup. And let's see, I think I would like to try, I'm going to try my garlic. And I'm going to just put it, I'm trying not to disturb the layer. Aha! So garlic has a really low density. Is that coming through on the camera? I hope so. You can see the garlic, it's floating in that layer of vegetable oil, so it's not very dense compared to, definitely not dense compared to the screw. Now, I like the example of the tomato and the grape because they are the same size, so we can compare a constant volume. So if they have about the same volume, I know it's not exact, but if they're about the same, but one sinks further than the other, we'll know that that is more dense. I can tell you just by feel that the grape feels heavier than the tomato. So let's see where they end up. There goes the grape, and it's suspended in the layer of dish soap, so it's floating right on top of the corn syrup. So that means that a grape is just slightly more dense than water. And the tomato is floating. Aha, so the tomato is floating kind of halfway between the dish soap and the water layer. So it is less dense than the grape because it's floating higher up. So remember, the density column, the most dense is at the bottom and the least dense is at the top. So we can compare the density of all these items relative to each other. And we know that so far the garlic is the least dense and the screw is the most dense. Here goes an almond. And I'm having a hard time seeing where it ended up. Okay, so the almond ended up in my water layer, so it has about the same density as water. Here goes my dried cranberry. And that's pretty dense, actually. I was surprised by that one. It's still sinking. I think I'm trying to rotate this carefully without spilling the whole thing so you can see kind of where things are ending up. And now my brick goes in, and it floated a little at first because it had air in the openings, but once it filled up with water, it dropped down. All right, so that brick is definitely less dense than the water layer. It's kind of floating almost in the oil. And the wood is very, very light compared to everything else. It's not as dense, it's floating. And then I think the most obvious one, does everyone think this will float? I do. Let's see. Yeah, so a ping pong ball has a very low density, and that's because it has so much space inside. It's just a thin layer of plastic, so it looks very big compared to what it weighs. So I think we made it all the way through. We got our 6 layers stacked into an awesome looking density column, and then we were able to compare a whole bunch of household items to see which ones are more dense and which ones are least dense, and we can rank them from most to least dense. So the screw and the die are the most dense, and let's see, I see my dried cranberry and my grape are next up the scale, and then the tomato and the almond, followed by the brick and the garlic, and then the least dense would be the ping pong ball and the wood ring. So that's the whole experiment. So how was this working? I think I explained a bit as I was going, but basically we can compare the density of all these items. The density is, again, a measure of how much mass is contained in a given unit volume. So lighter liquids have less stuff packed into them than the heavier liquids. And likewise, the less dense objects float on the individual layers in this column. So that's the end of the experiment. Thanks so much for watching our 6-layer density column experiment today. And remember to follow the Waters Facebook page for more STEM Live demos. And check in tomorrow for another STEM Live challenge. See you all soon. Bye.